This tutorial will show the basic procedural steps for designing a concrete frame in ETABS. Our model will consist of a 2-story, 2-bay by 2-bay building. Before running the design, check the Options Preferences command and review the default settings for concrete frame design. There are many options for the design codes, and for this example we will use the ACI 31899. You should also verify that the other default values are correct. Next, we define the various concrete frame sections to be used in the model. We start by defining a 24-inch diameter circular column with a concrete material property. Selecting the concrete material will allow the program to do a concrete frame design on this section. Next, click on the Reinforcement button and make sure that the design type is set to column with circular reinforcing. Columns may be designed or checked. We will ask that this section be designed. Next, we will add a rectangular section for a 24-inch square column. Again, set the material to concrete and click on the Reinforcement button. This time the reinforcement pattern will be rectangular, and we will ask that the column be checked for the specified reinforcing rather than designed. For this column, a stress ratio will be reported. Our last section will also be rectangular, but it will be a beam section rather than a column. Select concrete as the material once more and set the beam width to 12 inches. Click on Reinforcement and select the design type to be beam. Note that with the beam we no longer have the option for checking. Design for major moments and shears is the only choice. Now that the sections have been defined, the next step is to assign them to the model. Start by selecting all of the column line objects and assign the circular column section to them. This is the column that we want designed. Next, select all the beamline objects and assign the rectangular beam section to them. Lastly, select a single column object and reassign the square column section to it so that we can see how the column check option works. At this point, we have assigned the rectangular beam which will be designed, the circular column that will also be designed, and the square column that will be checked. We are almost ready to run the analysis, but before we do, make sure that the P-delta option is on, as this is needed to account for the global P-delta effects in the design. The local effects are included in the design algorithms. The analysis may now be run. With the analysis complete, we are ready to enter the design phase. A quick check of the load combinations shows the load combos that the program has automatically generated. You may view what is in these combos, or add or remove combos from the list. We are now ready to start the design check of the concrete frames. With the design complete, We will ask the program to display the design info on the left elevation in addition to that which is shown on the 3D view. Note that the required reinforcing values are displayed for the design beams and columns, while the column that was checked shows the area of the reinforcing that the user defined. A right-click on a frame object brings up a design information form, where you can review the particular design details for both flexural and shear design. Interaction surfaces for columns are also available. Similar information may also be displayed for the design beams. A right-click on the column that was checked displays the maximum capacity ratio. This concludes this tutorial.